Hello Tovarish, we are on the beautiful coast of the Black Sea to test the cheap flying wing V2. Well, the first wing we're gonna test is the one covered with dirt. I'm kidding, it's just solar film or monocoque. We forgot to turn on the good mic, so I'll spare you the pain and voiceover from now on. Now that's a fairly shaky takeoff. Because these are heavy wings and we were hand throwing them, I put 45-degree throws on the elevons for low speed control. We also launched in a bit of a side wind as the gusts kept changing direction. However, once I switched to lower throws, about 20 degrees, the experience got much smoother. This wing was flown with 5% static margin. You can see my first attempt at a landing didn't go so well, so I did a go around. I was expecting the wing to have a lot more drag. Well, we can consider that a relative success. Now let's try to fly the second one, which is about 300 grams heavier. The launch was quite wobbly because of the side wind, but the wing didn't have any bad tendencies aside from the inherently higher stall speed. The composite shell adds to the overall rigidity and strength of the design, allowing it to pull more G's and do more demanding maneuvers. Because of the rather large fins, both wings track really well, even at relatively low speed. Compared to my previous design, this one has slightly more forgiving flight characteristics, but I couldn't really tell you why. Even if I do say so myself, this is a significant improvement over the first design. The power to weight ratio of the composite wing is a bit low, but it can be hand launched with some headwind. Neither of them needed any vertical trims with 5 to 7% static margin. This version of the cheap flying wing is an iterative improvement over the first design. The main advantages of this version over the previous are an elongated fuselage nose, eliminating the need of nose weights for balancing and an increased sweep angle, moving the neutral point further back, basically fixing the tail heavy issue with the first one. Also, I'm sure you've noticed the vertical stabilizers. They are now 3D printed as well and are way better than the flat plates we used before. With that being said, the surfaces are the same, so you can still use the flat plates if you wish. Now let's talk about how we built these. Both wings were built using the exact same 3D printed parts and same plans. Also, they were both spec'd with identical A2212 motors. The major difference comes in the form of the covering material. The first wing was covered with a bootleg monocoque substitute. In this configuration, the covering material adds a bit of stiffness and almost no additional strength to the wing. On the other hand, it also adds very little weight while reducing drag. I'm not sure to what extent though, as the application is admittedly quite bad. I wouldn't advise trying to do an entire wing at once with this. One thing to note, the thermo-adhesive on our film refused to stick to PLA, so we had to stick it down with some scotch tape. The empty weight of this wing is about 710 grams. The second wing was covered in fiberglass and epoxy resin. The specific weight of the fiberglass we used was 50 grams per square meter. While significantly messier and more tedious to apply than the monocoque, a single layer of epoxy/fiberglass covering added an impressive amount of strength and stiffness to the wing, and I personally like the finish more than what we could achieve with solar film. This is in no small part due to the ability of the fiberglass to follow compound curves and complex geometries. Unfortunately, even after half a day of sanding and 2 layers of paint, there are still imperfections, especially in the areas where overhangs were present. This type of covering isn't very forgiving when it comes to mistakes and may require a second layer of epoxy. Comparing the weight of this wing to the previous would not exactly be apples to apples, because this method allowed us to have an almost continuous reinforcement from one side of the wing to the other, including the fuselage. Anyways, the empty weight of this wing ended up being 894 grams. You can see a detailed breakdown of the mass increase over the course of the build in this table here. The all-up weight of the composite wing ended up being around 1200 grams, while the film-covered wing ended up being around 900 grams. One thing to note is that the 2 layers of paint added about 80 to 90 grams to the overall weight. I would highly recommend using a dye in the epoxy rather than using a separate paint layer for this purpose. For connecting the elevons to the rest of the wing, I suggest using some small hinges rather than tape, but if you do use tape, make sure to use a decent application method. The winglets are meant to be printed in vase mode with 2 bottom layers and 2 to 4 top layers depending on your printer's bridging capabilities. Now these have some pretty steep printing angles, so you may need a bit of infill inside them, at least to a certain height, but make sure to take that extra weight into account if you do use infill. The fuselage pieces are supposed to be printed with about 15 to 25% infill, 3 bottom layers and 3 to 4 top layers, and 2 exterior walls. As always, you can find all the plans, source files including CATIA and XFLR5 files for free on my Thingiverse page. Link is in the description below. So that's about it, thanks for watching, I hope you found this at the very least interesting, if not informative. If you like what you see, hit that button, and for new content every 6 months or so, click the subscribe button. See you later.